Right. Good day, everyone, or hi, everyone. Um, Today we are going to be looking at physics. But let me first of all welcome you to our channel. This is a place where we can just call it science up to. This is a place where we learn about anything science, physics, chemistry, biology, especially for the O-level students. Okay. So I am Tutor Glycol, and if this is your first time of coming across our video, please make sure you like, share, and follow. And if you are watching this video from TikTok, you will not get the full clip. Yeah, it's just a cut out section. So make sure you go to YouTube and search for Tutor Glycol so that you can get the full video. And before I also proceed, I hope you have watched the last video on simple harmonic motion. So let's continue. Now, we're going to be looking at equilibrium of forces under this following objective. Firstly, we're going to be talking about understanding the concept of equilibrium. Now, in physics, many students are always afraid of calculation, but they don't know that in order for you to solve calculation, you have to first understand the theoretical aspect and the concept that thing is actually talking about. You cannot delve into solving question on equilibrium without you understanding properly what equilibrium is. So we're going to be understanding what equilibrium is first. We're also going to be looking at the difference between resultant and equilibrium force, and we're going to be looking at equilibrium force properly. We're going to be talking about equilibrium of three forces acting at a point. When three forces act at a point and they are in equilibrium, what will happen? We're also going to look at movement of a force. This is the dread of many students, how to solve movement. But don't worry, we're going to look at it here. We're also going to be looking at principle of movement. We're going to talk about parallel and coplanar forces, conditions for parallel and coplanar forces. We're going to look at movement of a couple, and we're also going to talk about conditions of equilibrium of non-parallel forces. So please stay to the end of this video so that you will not miss any part, because you can't tell if your next exam you'll be right to be seeing the question here. So if you are able to stay to the end of this video, any question at all, we're going to be checking some examples because I have a past question here with me. I talked that we're going to be looking at some post-UTME and some UTME past question, even wide past question. So let's get to business. So what is equilibrium first? That's the first thing we want to look at. That's the first thing we want to touch. What is equilibrium? Okay, so equilibrium first is actually, in a simple term, it means balance. Equilibrium means balance. So anytime you hear the word equilibrium, you hear in physics they say equilibrium of forces. In chemistry, they will tell you that chemical equilibrium. In biology, they tell you balance between ecological and stuff like that. So it actually means balance. When this side is equal to this side, that's what equilibrium means. So let's say something like this. If I have a fulcrum, there's this seesaw that we know, this thing that they normally call jangolova in a layman term. I have something like this. I hope you know, if I put a boy here and I do not put anybody, what do you think will happen? The thing will turn over side, right? But if I put an equal mass of a boy in this side here, the thing will still turn. Yes, it will still turn, because this boy, although both of them has the same mass, but then if you notice, one is at the edge but one is closer to the fulcrum. One side will still go to the other side. But until I place this boy at a point that is also at equal distance from this place, then of the same mass, both of them has the same weight, then this thing will not be stable. So when we say equilibrium is that point at which this seesaw, this seesaw, that's the English term, right? The point at which this thing becomes balanced, that's what we call equilibrium. So when we talk about equilibrium, it is the point at which this thing becomes balanced. And if you look at it, one of the reasons why at the first instance, the reason you notice that this side was coming down, the reason it was not balanced was because we placed a boy of a particular weight on this side. So that tells us that in physics, what brings about disruption in equilibrium is actually force. No, now if we not want to look at equilibrium in proper term, equilibrium of bodies can either be at rest, take note, or can either be at motion. A body can be at rest and be in equilibrium, and a body can be in motion and also be in equilibrium. Okay, so if a body is just like this without moving, without rotating, so when it is at rest, if it is not rotating and is not moving, it is in equilibrium. When it is in motion, a body is in equilibrium when it's motion, when its velocity is uniform. Don't forget that. That's a potential point. You can see it to your exam. A body moving with uniform velocity is in equilibrium. Do you know the reason? The reason is because as it is moving with uniform velocity, what is its acceleration? Acceleration is zero. And because acceleration is zero, there is no force. Remember, force produces acceleration from Newton's second law. Now, look at something Newton's first law told us. Newton's first law told us a body remains at rest or uniform motion unless it is acted upon by what? An external force. Unless an external force act on a body, it will be at its position. So equilibrium will be there unless something is acted upon it. Let me just take you a little bit to chemistry. Did you remember under chemical equilibrium, we said the equilibrium constant will remain there unless, you remember Le Chatelier's principle now? Exactly. If there's a change in concentration, change in pressure, change in temperature, any of these things can make the equilibrium constant to shift. Exactly. Once there's an application of force, equilibrium will shift. So in a layman term, or in summary of all I've been saying, what is equilibrium? Equilibrium simply means balance. When all the forces acting on a body is balanced in all respect. So if I have a body here and a force F is pulling into this direction, let's call it F1. The body keeps going, but if I bring an equal and opposite force and put it in this direction, then the body will be in equilibrium, to be balanced. So when the force acting on the body in all direction is zero or is equivalent to zero, when we add them together, it counterbalances each other, then the body is in equilibrium. So let's understand that. So equilibrium means what? Balance. So having said that, having discussed that, we are going to be looking at the next thing, differentiating between resultant and equilibrium force. This is very, very important that we know. Yeah, it's very, very important that I talk about this. So let's look at the resultant force first. The resultant force is the first thing we're going to be looking at in this video. Okay, let's move on. Resultant force. Now, the word resultant actually comes from resolution. The word resultant actually comes from resolution. When you resolved all the forces acting at the body, that's what resultant actually means. So when we talk about resultant force, what is resultant force? Resultant force is that single force. I will not be talking deeply on resultant force in this video, because if I'm beginning to talk deeply on it, it means that I'll be deviating from what I have here. So I just want to focus on what we have here. So I'm just going to be talking about surface level of resultant, but don't worry, I'm going to make a video on resultant force that is actually under scalars and vector. When we begin to look at scalars and vector, then we'll go intensely on this. So resultant force is actually that single force that will produce the same effect as the other forces put together. Let's look at something. I want to locate this direction, and I am currently here. So I decide to move this way and this way. But hope you know there's also another way for me to get here, just by moving this way in this direction. You see, I move 1, 2 to get to this destination, and I also moved 1. You saw that a single distance produce the same effect as two distances put together, or a single displacement produce the same effect as two displacements put together. This single one is what we call resultant force or resultant displacement, if it's displacement you're looking at it at. So resultant force is actually talking about that single force that will produce the same effect as the other forces put together. Let me give you a real life issue now. Let's say there's a particular bag on the ground, and 3 children are trying to drag this bag. They're trying to drag this bag, and as they're dragging the bag, they're even struggling in dragging the bag. But then all of a sudden, you just carry the bag and you dragged it. You saw that the effect produced by these 3 children, only you brought about that effect. You are the resultant force. So what we're trying to talk about anytime we look at resultant force, it is actually that force that will produce the same result as every other forces put together. It does not necessarily mean that it must just be 2 forces put together. It can be 3 forces, 4, 5. As many forces put together, that single force that will produce the same result as all these forces put together is what we call the resultant force. Don't forget this. This is why we call it resolve. You resolve all the forces together. You bring all the forces together and give you one equation. So if I add force A, B, C, D together, in all respect, I want to add them, the result is going to give me. That's what we call the resultant force. Are you with me now? Now, there is actually a law that actually helped us to understand the concept of the resultant force. There is a law. Now, what is that law? It's called the parallelogram's law of vector. I'm not going to be looking at that law in this video because that's under scalars and vector, but I want to borrow something from that law. Now, look at what, before I explain that law, it is proper I will understand what a parallelogram is. Let me show you something. So, a parallelogram is a quadrilateral that has 4 sides. So, you look at it like this. And from what we know in mathematics, we know opposite sides are equal. So if I call this side L1, this side will also be L1. If I call this side L2, this side will be L2. Is that not the opposite side are equal? So what parallelogram law of vector is trying to say? Before I even prove, let me tell you this. If you are somebody who want to study or know physics, if you don't know math or have a good mathematics knowledge, it will be difficult for you to understand some concept. So maths and physics go hands in hand. So let's go back to what we have here. So this is a parallelogram, right? Opposite sides are equal. Now from the parallelogram law of vector, it's trying to tell us that if in a case we have two forces acting like this, with having a meeting point, like this L1 represents force 1, L2 represents force 2. So they now meet at a point like this. The diagonal of the parallelogram actually represents the resultant force. So if I draw a diagonal like this now, this diagonal is actually representing the resultant force we are talking about. So what does this mean? If this parallelogram law is, see this is what I say, what does this mean? If I have two forces acting at a point, meeting at a point, the resultant of those forces is actually drawn from the meeting point of those two forces. So I have force F1 and force F2. The resultant is this one here. So this is the resultant force. So I want to bring this diagram up here. So this is F2, this is F1, right? This is the resultant force. Now if I draw a broken line to form a shape, maybe let's say a rectangular shape, and this rectangular shape, now if you look at it, this rectangular shape is forming two right angle triangle, up, down. This is a right angle triangle, this is a right angle triangle, and I decide to take this one here, this particular right angle triangle, the down part of that right angle triangle. If I decide to take that one, now remember, opposite side are equal. If this is F2, this is supposed to be what? F2. This is F1, this is also be what? F1. Is that not it? And I'm taking this now. What I'm trying to show to you, that I want to show to you a particular law, how they got a particular thing, but just follow me now. Keep following me. So I took the down part. I will have something like this, right? This is F1, this is F2, and this is the resultant. Is that not it? So F1, F2 result. So what do we have here? We have a right angle triangle. Since we're having a triangle, this is why I say physics and maths go together. So when you have a case where you have a triangle like this, you can actually use some of the laws you use to solve triangle to solve this. You are going to understand this concept clearly when I talk about equilibrium of three forces. Okay, so there are two particular rules we use in solving right angle triangle those days in mathematics. They would call it, the first one is called the SOHCAHTOA. Most of you who did junior mathematics, you know what I'm talking about. SOHCAHTOA. And the other one is Pythagorean theorem. Is that not the Pythagorean theorem and SOHCAHTOA? So what does this SOHCAHTOA? This SOHCAHTOA is actually used to find angles in the right angle triangle. Pythagorean theorem is actually used to find the sides. So since this thing represents a triangle, and we are using this triangle to pick our important forces, we can actually use these two rules to solve any side. So if I'm asked to find any of these sides, I use Pythagorean theorem. So what does Pythagorean theorem tell us? He told us, or tells us, that the sum of the two sides, the sum of the square of the two sides is equal to the square of the hypotenuse. So hypotenuse square, okay, let me show us this. The longest side of a right angle triangle is the hypotenuse, right? Hypotenuse. The side facing the angle, if this is the angle we are talking about, if this is theta, the side facing the angle is the opposite, while the third side is the adjacent. Many of us don't know how to get opposite adjacent in that, but I'm teaching you now. If this is the angle you are referring to, theta, then the side facing, so opposite and adjacent does not have a particular place in a right angle triangle. It is only the hypotenuse that has a particular place. When you say a right angle triangle now, the first thing you do is locate the hypotenuse. The hypotenuse is the longest side. So just look at, this is the hypotenuse. Then if you want to know opposite and adjacent, it is the angle that will tell you. The side facing the angle you are referring to, not the 90 degree, the other angle, the side. If this is the angle the question is actually referring to, the side facing it is what we call the opposite. If this is the angle you are referring to, the side facing it is actually what we call the opposite. So if I'm talking about this angle, this is my opposite, this is my adjacent. If I'm talking about this angle, this is my opposite, this is my adjacent. Are we getting it now? So Pythagorean theorem is telling us that hypotenuse square is equal to the sum of the two other sides, opposite square plus adjacent square. So this is what the Pythagorean theorem is telling us. I'm trying to show us all of these things because when we begin to solve questions, we will not be asking how did this come, how did that come, and how did that come. I'm trying to derive to you now. I'm trying to bring, you don't need to know, you don't need to cram all of this in. All you have to know the formula you need to know and get to your business. So what about this SOHCAHTOA? It's actually used to solve angle. So means sine, ka means cos, tua means tan. So what does this mean? If I have a case scenario that I need to find a particular angle, the known sides given to me will determine which of these I will use. Let me show you what I'm talking about. It is the known side that will determine which of those SOHCAHTOA I will use. if I am given F1 and F2 and I'm giving this angle, I want to find this angle. Let's use this particular angle. I'm giving, that is, when I say known side, I mean side that values were given. They tell you, okay, this side is 2, this side is 3. Find theta. So if I'm giving these two sides now, right, these are the known side, and I want to find theta. So since this is the side facing the angle is opposite, so this is my opposite and this is my adjacent. Among this one, which one has opposite and adjacent? This is O and A. O means opposite, A means adjacent. So it means that to find this angle, I will use tan. So I'll say tan theta is equal to what? Opposite over adjacent. So since this side is representing opposite, it will be F1 over, since this side is representing adjacent, it will be over F2. Do you see that now? As easy as that. If I'm given this side and this side, and I want to find the angle, so since this is the angle, this will be the opposite, this is adjacent, this is hypotenuse. So which one is representing adjacent and hypotenuse? That's cos. So if I want to find the angle now, I'll say cos theta is equal to adjacent over hypotenuse, and that's F2 over R. Are you following me? And then if I'm giving this side and this side, that'll be sine theta called opposite over hypotenuse. So that's just the basic tools we use to solve any questions on this any question dealing with resultant force. Now this particular resultant force I helped you to understand now is actually for two forces. When two forces meet at right angles, when two forces meet at right angles to each other, when they are, that's I'm specifying it now. When the two forces are meeting at right, that is the angle between the two forces is 90 degrees. That's when we use this one. There are cases where the angle between them is 45 degrees, 60 degrees, and so on. Obtuse angle, acute angle, and so on. But in those cases now, that's where the parallelogram law of vector will fully come. But that's not what I'm talking about. That's under scalars and vector. I said that at the earlier part of this video. That we are going to be precisely looking at the surface level of resultant force, because that's not our key model for our objective. We just need to have idea of what resultant force is, because we need to know our equilibrium force. This is why I'm just touching the surface level. When I make a video on scalars and vector, then we'll now talk about this resultant force properly. Look at the solution of two or more forces. Okay, so let's know that. Now, I haven't touched resultant force. Now, what is now the equilibrium force? What did I say resultant force is at the earlier part of this video? I said it is that single force that produces the same effect, the same result as the other forces put together. Is that not it? Good. So let's now look at equilibrium force. What is equilibrium force? Equilibrium. This is the force of equilibrium. Equilibrium force is actually that single force that will bring a body to equilibrium. Resultant force is that single force that will produce the same result as the other forces put together. Is that not it? Equilibrium force is that single force, that other single force that will bring a body to equilibrium. So see, the key difference between resultant and equilibrium is that resultant force actually will produce motion. Yes, resultant, imagine, let me show you something. So I have a car, or I have a body here. Three forces is acting on this body. Is that not it? Obviously, in reality, you know that this body will move to the right. Since these three forces are acting at least right, you know that this body will be moving to the right. The only way to not move to the right is when there is friction that counterbalances it. So I'm not even going deep into that, but in reality, you will see that this body will be going to the right. Is that not it? So this force, first force is 2 Newton, second force is 2 Newton, third force is 2 Newton. So the force, the total force that is making this body move to the right, is it 2 Newton? No, it is 6 Newton. So 6 Newton is the force making this body move to the right. This 6 Newton is the resolved version of these three forces. That is, we are adding these three forces together to give us this 6 Newton. This 6 Newton is what we call the resultant force. Now, if I now ask you now, what must be the force I must add, or what must I do to stop this body from moving on? What should I do to stop this body from moving to the right? It means that I must apply a force. There are two things I can do. One, remove this force, right? Remove the three forces that is acting on it to make it stop, or apply a force that has the same value, the same magnitude as these three forces in the opposite direction, so that it will come to a stop. Is that not what I need to do? Good. The forces I will act here, it can either be 2, can be 1, can be 3, but then anytime we look at equilibrium, it is actually one force. So what is that one force that I must add to this thing that will bring it, that will make it to come to a stop? It will be what? One single force called 6 Newton force. So you see that the 6 Newton single force now that is acting in the left direction and 3 forces acting in the right direction. These 3 forces like this combined gives us this 6 Newton. This 6 Newton is the resultant force, because we are resolving the 3 of it, is the resultant force. Then this single force that, and you see that the resultant force is actually just one force. The resultant force is also one force, because it is the resolution of the other forces put together. We say it is that single force that will produce the same effect as the other forces put together. So this 6 Newton is that one force, resultant. What is that single force that will put, that will make it come to a stop? Is also 6 Newton, right? So imagine I now put that 6 Newton force that will bring it to a stop in the same direction. What will happen? The body will move on again. So for it to come to a stop, that 6 Newton must be at the opposite direction. So this 6 Newton that will bring it to a stop, or that will bring it into equilibrium at rest, is what we call the equilibrium force. So what do we notice here? We notice that the equilibrium force and the resultant force are 2 forces of the same value, but in opposite direction. This is why in your textbook you will see that resultant force is equal to minus E. The minus here does not necessarily mean that E is negative. What it means is that it's showing direction. It's trying to tell you that both the resultant and the sign equal. It's trying to tell you that what is here is the same as what is here. That's what the sign equal means. So if I have equal here, it means that what is here is what is here. Arrow and E have the same value, but this minus is trying to tell me that both arrow and E, they have the same value, but then they are in opposite direction. And this is the illustration I'm showing to you here. Resultant force and equilibrium force, both of them has the same magnitude, the same value, but they are in opposite direction. So it means that if I can get my resultant force, definitely I've gotten my equilibrium force, but I will know that my equilibrium force is opposite in direction to my resultant force. This is why you're always having this illustration every time in your textbook. So you look at your textbook, you see arrow equals minus E. Minus most time in physics is not necessary to show that the value is negative. It is in mathematics we see that minus means, oh, this thing is negative in what they call that number line, oh, this is negative. But in physics most time minus does not mean it is negative. It means it is opposite in direction. And you always see this occurrence in relative velocity. When 2 velocities are coming down in opposite direction, one is relating to another, you will see they will put minus for one and they will put plus for one. That minus means that they are moving in opposite direction. Does not mean the value is actually negative. Are you following me? And this is why, especially when we are dealing with vector quantity, if you get your final answer as minus, you don't have to say you are wrong. You know, there are some people who will solve some questions in physics, they will get minus, they'll say no, minus cannot, no, it can be correct, because minus there actually does not mean it is negative. It doesn't show direction. There are some questions you will solve on projectile, you will get velocity to be negative. What it actually means is that it does not mean it is actually like negative in value. It means the direction is opposite to the initial direction it was going. Are you with me? Don't worry, I'm here with you guys. I'm going to be demystifying some things for us. So this is actually what the resultant and equilibrium force actually means. So let me bring us back to an explanation I just made on these 2 forces. So remember that when we drew 2 forces like this, we said the resultant force will pass through that, it will cut through their center. So if this is resultant force and this is the direction of resultant force, pause this video and tell me where would the equilibrium force will go. Good. Equilibrium force will be here. E. This is resultant force, equilibrium force. So once I get my resultant force, I should be able to get my equilibrium force. Are you getting what I'm saying? Exactly what I've been trying to show to all. So this is actually how resultant and equilibrium force are related. Now I'm going to be showing us a particular question in the textbook. Let me show us a past question. There's a past question I saw in the textbook. So this is how they drew the past question. I think that's a post-traumatic question, but let's just look at it together. They drew it here. They said this is 20. I'm not going to write the question, but I'm going to read it out for us. But these are the Judy 2019. Now, another thing I want us to take note of anytime we're solving question or equilibrium. Under equilibrium, there are various rules. There are rules. I've just showed us some rules. Socrates and Pythagoras. So there are rules you follow under equilibrium. Although that Socrates and Pythagoras is from mathematics, but it is borrowed in physics. See, anytime you want to solve any question on equilibrium under equilibrium, please, you have to take note of this, because assumptions are usually made in physics, and this is why many students fail questions so much. You don't assume in physics, you follow principle. If you want to use the principle of any of these, please always know the question will always tell you explicitly that this body is in equilibrium. Unless the question tells you that. If the question does not tell you that, don't bother assuming that, oh, this thing. Don't assume. Treat it as though that the question told you. So let's look at this particular question from this past question. Now look at what the question says. The question says that it says a particle P. So this is the particle P. A particle P is acted upon by 2 forces a particle P is maintained in this equation. A particle P is maintained in equilibrium by two forces, 20 Newton, 20 Newton. One is 20 Newton to the x direction, the other is 20 Newton to the y direction. Are you following me now? So 20 Newton, 20 Newton. Now the question I asked us that it said, see the diagram, and a third force F, which is not shown in the diagram. The force F is what? Now look at, you can see that question is tricky. Many of us will see that question in the exam and will guess the answer. Look at what the question. The question said that a particle P is maintained in equilibrium by two forces, 20 Newton to x, 20 Newton to the y direction. If this particle P is maintained in equilibrium by a third force F, what is this third force F? They say we should look at the diagram. In the diagram, they do not show us the third force F. They only told us that one is this, one is this. What is the third force F? We don't even know the third force F, but then this is what we can do. We already know that if this particular body is to be in equilibrium, number one, we have to first of all find the resultant force, and we have to know the direction of the resultant force. Once we can get it, because the only thing that can bring, because these two, now you have to understand this. So I want you to follow me. Now this is 20 Newton to y, 20 Newton to x. How do I know? Because the force that will bring it to equilibrium can either be here, can either be here. Any of these directions, the force can go. It can even be here. The equilibrium force can be in any direction, but we have to get the required and the necessary direction. This is why physics is not an assumption. We have to know the required direction. I can draw my equilibrium force here and put it there. I can do that. But is it correct? So for me to know the third force, now we already know that the third force is equilibrium force, because the question told us that the body is in equilibrium. Definitely the third force will bring it to equilibrium. So my equilibrium force can be in this direction, any direction, but then I can't assume, I can't guess. I have to be sure that okay, this is the direction my equilibrium force is. So in order for me to get that, I have to know my resultant force. It is my resultant force. If I can get the direction of my resultant force, definitely I can get my direction of my equilibrium force. So we already know from parallelograms law of vector that resultant force will always cut through the center of the two forces, right? So definitely I know my resultant force is this direction. If my resultant force is this direction, then my equilibrium force will be in that. Are you getting me now? So now, this is why I said it is proper we know resultant force, because the resultant force will show us equilibrium force. There's a particular explanation I used to use to give anytime explaining resultant and equilibrium. And what is this? In physics, there's actually a place called optics that talks about light and mirror image and the rest. No, there's one thing in plane mirror. In plane mirror, the image and the object have the same height, the same distance, everything the same. That's in the image of plane mirror. The only difference is that they even have the only difference is that they're opposite here. They're opposite. One is facing it laterally inverted. That's just the only difference. Good. So similarly, the equilibrium force is like the mirror image of the resultant force, and the resultant force is the mirror image of the equilibrium. They are just opposite. Both of them has the same thing, the same size, the same magnitude, but they're just opposite to each other. So if I can get my resultant force, I can get my equilibrium force. So since my resultant force is cutting directly through the center of the meeting point of the two forces, the angle between it is 45 degrees to my resultant. So now we're using Pythagoras triangle, because this will form a right angle. I've shown it to us in the last part. This will form a right angle triangle. So we will find our resultant force. So what is our resultant force? Oh, I showed us our Pythagoras triangle now. So this is 20 Newton, right? So this side will be 20 Newton 2. This is 20 Newton 2, right? So we'll be having something like this. R 20 Newton, 20 Newton. This is F1 and this is F2. So if we use Pythagoras theorem, hypotenuse square, our hypotenuse in this case is our R square is equal to sum of the square of the two sides, F1 square plus F2 square, right? So if I want to find R will be equal to square root of F1 square plus F2 square. This is the formula you used to see in your textbook most time. That's how they got it. So what is my F1 and F2? 20, 20. So my R will be equal to square root of 20 square plus 20 square, right? So my R will be equal to root 20 square is 400. 20 square is 400. 400 plus 400, that's 800. Square root of 800 will give you 20. Is it 20 root 2? Yeah, 20 root 2 Newton. That's how they got the result. Now, it is not resultant the question asks us to find. The question says the body is in equilibrium. Find the third force. That's the force that will bring it to equilibrium. So what we are looking for is our equilibrium force. So if my resultant force is 20 root 2 Newton, it means my equilibrium force is what? Is also 20 root 2 Newton. Now I've got my equilibrium force to be 20 root 2 Newton. How do I now know direction? Because most time when they give you questions like this, you will always need to find direction. Now let's see the option. Option A says 0 Newton. B says 40 Newton at 45 degree to X. C says 20 root 2 Newton at 45 degree to X. D say 20 root 2 Newton at 225 degree to X. I know many students will pick 20 root 2 Newton at 45 degree to X. If you pick the answer, what you just look for is your resultant force and its direction. But the question said about equilibrium force. The third force must be the equilibrium force because the question said it is in equilibrium. It's not in motion. If the body was in motion, then we'll know that it is the resultant force because that will produce motion. Equilibrium force will bring it to a stop, will bring it to equilibrium. We will stop the resultant force. Are you with me now? So I've gotten our value for equilibrium force. Now let's find the angle. So look at it. You know, the direction of measurement of our angle is this direction. You can see 45 degree, 90 degree. So if we want to get our equilibrium force, we also have to find it in this direction like this. Are you with me now? So I will draw it out. This is how it looks like. Let me just erase some parts. Let me erase some parts so that we can get what I'm saying. So I want to draw it where. So it's something like this. This is R. This is E. This is 45 degree. This 45 degrees actually is actually our angle for the resultant, but we're looking for angle for equilibrium. So it will be from here down to here. So from here to here is a straight line. Angle on the straight line 180. So from here to here is 180. Here to here is 45. So 180 plus 45 give us 225 degrees. Please make sure anytime you are solving question in physics, any question you are solving, that this is the angle. Make sure the angle is to the horizontal. Very, very important. Make sure it's to the horizontal. So the correct answer to this question is 20 root 2 at 225 degree to X. That's the correct answer. So you can see how we solve question on resultant and equilibrium force now. Very, very easy. Now let's move to the next. We have done that part now. We're moving to the next one now. The next one is equilibrium of three forces acting at the point. Now I want to ask us a question. Have we ever seen something like this? Let me show us something. Have you seen something like this? In a question, maybe you came across a question, see something like this, and they said this is the weight, this is the force, this is tension. Many of us have seen questions like this, right? And they will not ask us that we should find T, we should find F, and we'll be confused on how we are going to solve it. It's actually very, very easy. So the next thing we are looking at here is this equilibrium of three forces. Equilibrium of three forces acting at the point, triangle of forces. Now, the first thing I want you to understand is that anytime they tell us equilibrium of three forces, it means that three forces are in equilibrium. Three forces are in equilibrium. So this force, they are in equilibrium. They brought this particular body to equilibrium. So equilibrium of three forces is actually helping us understand that when three forces are in equilibrium, take note, there is a principle. What's the principle for it? Say that the principle of triangle, we call it the principle of triangle forces. Well, anytime three forces are in equilibrium, the principle we use to solve it is triangle forces. And these are most cases you'll be seeing a question like this. The principle states that if three forces act at a point, there are three conditions for this. So if three forces act at a point and they brought the body to equilibrium, are you with me? Then we can represent the three forces with the sides of a triangle, because a triangle is a shape that has three sides. So these three forces can be represented with the side of a triangle, just as we use parallelogram's law to solve resultant force. The same way we can use principle of triangle forces to solve three forces in equilibrium. So three conditions before this thing will be true. Before we use these three conditions, one, the forces must act at a point. What does it mean? This force is acting here, this force is acting here, this force is acting here. So these three forces are acting at a point. First condition met. Second condition again is that the three forces must bring the body to equilibrium. That is, all of these forces acting at this point, it must bring it to equilibrium. Second condition met. Third condition is that there must be three forces. So 1, 2, 3. So if these three conditions is met, then we can use the principle of the triangle forces. We say that we can represent it with the side of a triangle. And I put it to you, I have solved so many questions. Any question that deals with it, as long as it's jammed like most O level, it is always a right angle triangle. So how do you solve question like once you see this, first thing that comes to your mind, draw your right angle triangle. You can't tell me you don't know how to draw right angle triangle. So this is how it looks like. Your right angle triangle can be in any shape, and it works for any shape, any kind. You want to turn the right angle triangle upside down, or you want to put it anyhow. So I'll just draw my own like this. I'll draw 3 for us so that we'll know that it can work anyhow. So these are my, don't mind the shapes, but these are my 3 right angle triangle. Okay, so now look at the 3 forces. Among these 3 forces, which one is acting directly down? The weight. So this side is weight, this side is weight, this side is weight. Which one is acting horizontal? F. So this side is F, this side is F, this side is F. Which side is acting? So if you know these 2 sides, then definitely the third side is T. So T is the hypotenuse. Are you following what I'm saying? I'm not saying this side cannot be changed, but what I'm trying to tell you is that if you see it like this, is how you represent the 3 sides. So you see now, the principle tells us that we should represent when 3 forces 1. This is the principle. The principle says that when there is 3 forces acting at a point, 2 conditions, and they brought the body to an equilibrium, the 3 forces can be represented with the sides of a triangle. So first thing, when you want to solve question on it, represent it with the sides of the right angle triangle. Now, when you have represented with the side of the right angle triangle, now another thing they will give you again, they will give you angle. You can just say this side 30 degree. Now the issue most students used to have is how do they bring this angle into this shape? It's very easy. So if I look at this shape, the tension, which is the hypotenuse, is making an angle with the vertical, not with the horizontal. So definitely I'll look at the place where this tension is making angle with the vertical. This is it here. 30 degree. 30 degree. 30 degree. If it is in this side, 60 degree, then it will be here, 60 degree. So if here this is where the angle is, then it means that the tension is making the angle with the horizontal. So it will be here, here, and here. As simple as that. It's not difficult. So when you have been able to locate these 3 things, then there are 2 things we can do here now. We have been able to represent our force using a triangle. Now it's how to solve. The question can either say find T, find W, find F, or find the angle. Any of these the question can say you should find. So it now depends. If the question say find W, and they give you this side, you can use Pythagorean theorem. If the question say find the angle, you can use Soccer, which I've already explained. So let's take an example to see that what I'm saying is actually true. Let's just see an example. We'll just see like 2 or 3 examples under this one, and then we'll move on. Okay. So let's look at 2 examples. Now look at this particular example they gave me here. I'll draw the diagram. I'll read the question, but I'll draw the diagram. This is how the diagram will look like. 30 degree. X. F. Now listen to the question. The question says, a body X shown in the diagram has a mass of 6 kilograms. The body has a mass of 6 kilograms. Okay, and they went on and said, and is held in equilibrium by a string and a horizontal force F. It's held in equilibrium by a string. The string has tension T and an horizontal force F. This body has a mass of 6 kilograms. Now the question has said, find the tension in the string. Find the tension in the string. We should look for T. What is T? Okay, so definitely this is a body. It has a mass, so it will have what? A weight. So the weight will be 6 times 10, right? That's 16 newtons. If you are confused on how I got 6 times 10, remember weight is equal to what? Mass times gravity. Gravity is, they gave gravity there to be 10. So G is 10. So our formula for weight, W is equal to mg. So that's 6 times 10. That's 16 newton. Now look at what I've got. These are the 3 forces. The question told us that the body is held in equilibrium. So first thing is, according to the principle of triangle of forces, he said that 1, there must be 3 forces. So we have 3 forces: weight, force, and tension met. Then the next thing is the body must be in equilibrium, and the question told us that it is equilibrium. So second condition met. The next thing is 3 of them must act at a point, and they are acting at a point. Third condition met. So we can represent it with the side of a triangle. So I'll draw my right angle triangle. Now from this is 90 degrees. So now I want you to label this thing for me. Pause the video and label this thing for me. Good. So let's continue. So this is with the vertical. That's 30 degrees. So here will be 30 degrees. Here will be my tension. Horizontal will be my F, and here will be my W. So now let's say we should find T. Is that not it? We have. They did not give us F. They gave us weight to be 16 newton, and we're finding T. So there is no way we can use Pythagorean theorem to find T because F was not given. So we have to use Soccer too. So they gave us the angle. They gave us this side, and we're looking for this side. So I said the side facing now. Since this is you see that they gave us this angle. It is this angle that will determine our side. Now, the side facing this angle is is the opposite. This is adjacent, this is hypotenuse. So we have adjacent, hypotenuse. So what will go? Cos. So that'll be cos, that's cos, so cat1 and cos 30 degree is equal to adjacent 60 Newton over hypotenuse T. Cross multiply. T is equal to 60 Newton over cos 30. Press your calculator, you will get, let me press calculator, 60 divided by cos 30, 40 root 3 Newton. So the answer is 40 root 3 Newton. I've gotten that. If the question also says you should find F, opposite over adjacent, that's tan. Tan 30 is equal to opposite F over 60 Newton. You can see the way I'm solving it. Just cross multiply. F is equal to 60 times tan 30. What will it give you? Just press your calculator. 60 times tan 30, 20 root 3 Newton. Do you see this now? Now somebody will ask me now, sir, but you are using calculator. What about us that are preparing for exam like post-term and JAM, and that they don't give us this casual calculator? How do we do? This is it. As a physics student preparing for any exam like post-term and JAM or WAEC, WAEC used to give calculator, but post-term and JAM most especially, they will not give you calculator. As a student, you should be able to know. The reason I'm even using calculator so that I'll be fast. I don't want to start making. You have to know the angle for 30 degrees, 60, 45, and 90. No cos, tan, and sine for 30, 60, 40. These are the notable ones that I use for examining. For any exam, these are the notable ones. If they will give you anything aside from it, they will tell you take sine this to be this. Some questionnaires might be kind that they say, okay, take tan 30 to be this, just to help you far. But some will not put it. They will not always put it. But so know it. No cos 30. Cos 30 is what? 0.860. Sine 30 was 0.5. So know them on your head before you get to the exam hall. So when you just see it, and don't just know the decimal form, know the surd form. In mathematics, surd 2 root 3, know the surd form, root 3 over 2, 1 over 2, 1 over root 2. Those are the commonest ones. So know them. Like sine, I think sine 45 and cos 45 is 1 over root 2. Cos 60 is 0.5. Sine 60 is root 3 over 2. These things, know them. While I was preparing for JAM those days, I know all of these things. I'm in 400 level medicine now. What I want to do? So know them. You understand? Know them when you want to enter the exam, or know them and you will see. So let's move on. Let's see another question. So this is how we solve it and get our answer. Let's see another question. I hope we are learning. We'll look at another question and then we'll move on, just to show us how questions like this are taught. So look at this particular question I saw. They drew the diagram like this. Okay, and they said something like this. They label this as theta. This one is the tension T, and they say the tension is 10 Newton. They put a force F, 5 Newton, and they said the weight W. So let me read the question for us. A particle P of weight W is in equilibrium under the system. This is what I'm saying. The question must tell you that the stuff is in equilibrium before you can assume it's in equilibrium. If it does not tell you, don't go and be assuming. It's in equilibrium under the system of forces shown in the diagram. Find the values of W and theta respectively. I will ask you to pause this video, solve it on your own. Let's see if you get the same answer as what I will get now. So let's go. So first, we have, since it actually fulfills those three conditions. So we'll use a right angle triangle. Let me use this direction. Right? So tension will be 10 Newton. This is my 10 Newton. This is my weight W. This is my angle theta. And this is my 5 Newton. I don't need to be wasting time again for all this. So to get W, since they give us two sides, we can use Pythagorean theorem, right? So hypotenuse square, that's 10 square, is equal to the sum of the two other side. I mean the square of the two other side. Is that not it? So take this one to this side. We have W square is equal to 10 square minus 5 square. I'm just shortening the stuff so it'll be fast. It's not what I just did. Hypotenuse square is equal to opposite square plus adjacent square. We're looking for W. Right, so we'll say W square, 10 square is 100, 5 square is 25. 100 minus 25 is what? Is 75. So W will be equal to square root of 75. That's 25 times 3. That's 5 root 3. I've just used surge to solve this now with that calculator. That's 5 root 3 Newton. As easy as that. Another way you can use to get this is this. But before then, let's get our theta. So let's go. The side facing the angle is opposite, hypotenuse. That's sine, right? So that will be sine theta is equal to opposite, which is 5, over hypotenuse, which is 10. 5 here 1, 5 in 10, 2. So sine theta is equal to 1 over 2. 1 over 2 is what? 0.5. So use your calculator to progress arc sine. By now you should know. See, without anybody, that as a physicist, without anybody telling you, should be knowing some of these things already. I already know that if I'm to find the arc sine of 0.5 to give me 30 degrees, I don't need to press calculator. Know them, because sine 30 is 0.5. It's like your opposite, like they are inverse. If sine 60 is 0.8660, so if I want to find arc sine 0.8660, it will give me 60 degrees. Exactly. So my theta in this case will be arc sine 0.5. That's 30 degrees. So I've gotten my theta. So if I get my theta first and I want to get my W using my theta, it's very easy. So if I get this theta to be 30 degrees now, I'll simply say opposite or adjacent over hypotenuse. Is that not it? That will be cos theta is equal to, what's the adjacent? W over 10, which is the hypotenuse. What I'm trying to do is, I want to show you another way apart from the Pythagorean theorem that we can use to get the W. And I said, if I want to show you another way, I have to get my angle first, which I have done. I got my angle to be 30 degrees. So now, so let's use SOHCAHTOA. Since I'm looking for W, adjacent over hypotenuse. This is adjacent over hypotenuse. Because the answer is, the theta there is 30 degrees. So we'll simply say cross multiply. W will be equal to 10 times cos 30. Cos 30 is 0.860. If you multiply by 10, it give you 8.66, and that's the same thing as 5 root 3. You can also use tan. Yes. Look at it. Theta will be cos, because right? Adjacent over, okay, you cannot use tan. I think you can't use tan. Okay, you can use now. Look at opposite over adjacent. Yes, you can use tan. Opposite over adjacent. So you simply say tan 30 is equal to opposite 5 over adjacent. W will be equal to 5 over tan 30. Use your calculator, you get the answer. So I've been able to cover this one now. So you see that it's not difficult. It's not actually hard. Physics is not difficult. So I've been able to look at it. So what this particular one is trying to tell us, anytime they ask us that three forces is in equilibrium under the a body is in equilibrium under the action of three forces meeting at a point, just remember the triangle of forces and you'll be able to get your answer. Now before we proceed, there's something I want to also show to us. I want to use one stone to kill two birds. This is actually something you will use, you will need, you can use, because look at something now. There are many a time I've seen many students during the days I was preparing for JAMB at Postemi who have experienced a lot of stuff. In those days that we used to brainstorm and do all the rest. Now look at something. There's this particular question they will tell us, they will draw something like this. They'll say this is tension T, this is tension T, this is theta, this is theta, right? And they will tell us that this is the weight of the body, W. Many of you might have seen, if you are somebody who is conversant with past question, you would have seen something like this. There are two ways to describe this question. One is picture. They will say a picture is held by two strings and nailed to the wall. This is the picture, two string. You now ask to find the tension or find the weight or find the angle. They can ask you any of these things. Another thing they will tell you again is a boy held a bucket of water with his two hands on a string 1, string 2, at an angle of theta, and the weight of the bucket is down. Those are ways they can ask you these questions. So when you see questions like that, how do you solve it? Many a time, what many students used to do, they will go ahead and say use Lami's theorem and tend to confuse us. They don't even know which angle to use. But let me show you an easier and quickest way to solve this thing. I'll be deriving it. I'll be showing you the derivation. But then, when I get to the final answer, I will tell you, since you are preparing for, it's only in WAEC you can do all those ones to get mark. But if you are preparing for JAMB and Post-Tem, nobody send you how you get your answer, but just get the correct answer. So if you are preparing for JAMB and Post-Tem, I will tell you that you should rather use the final answer I've got to solve the question. I'm going to explain better. But before I explain this thing, many of us don't know what it means by resolution of forces. Now, I want to really chip in this thing. It's not also part of it, but I want to chip it in. Look at, if you are dealing with angle, this is what we call horizontal. Are you with me? This is what we call vertical. Most things are relative to the ground, horizontal. So when I say anything in my video and I say ensure your angle is to the horizontal, I mean that ensure that thing you are dealing with, the angle is making is to the ground. So if I have something acting in this direction and I say ensure your angle is to the horizontal, I mean make sure the angle is like this. It's always make sure it's always touching this horizontal, it's always touching the ground. Whether it is a line, whether it's a, make sure it's always touching. This is what I mean by horizontal angle. This is also horizontal angle, but in the negative direction. But what do I mean by a vertical angle? This is what I mean by vertical angle. If I have something like this and I have something like this, then I have something like this. This is a vertical line V. This is a horizontal line H. An angle to this side is called horizontal angle. An angle to this side is called vertical angle. So if the line is touching the vertical side, if it's touching this straight line, it is called a vertical angle. If it's touching the one on the ground, it's called the horizontal angle. So this is where I'm going to. Anytime you want to solve questions in physics that deal with angle, unless stated otherwise, ensure the angle is always to the horizontal. Always make, even if they give you the angle to the vertical, change it to the horizontal. There is a reason I'm saying so that many students, as because of this confusion, fail many questions that they even know. They fail it. Not as if they don't know it, because they misinterpreted this. Now let me show you something now. If the angle, now remember when we are dealing with vector, I've not taught vector yet. I'm going to make a video for it. When we are dealing with vector quantities, once a vector quantity is making an angle, it is the best thing to do is, once a vector quantity is making an angle like this, the best thing to do is to resolve the vector quantity to the vertical direction, or to the, you always resolve it either to the horizontal or to the vertical. And there are two ways. When you are resolving to the vertical, from small or from secondary school, they have told students that anytime you want to resolve, anytime you are resolving to the anything horizontal component is cos, anything vertical component is sine. This is true, but to some extent. This is why I want to show us something. This is true, but to some extent, and this is the reason I'm always telling us that take the angle to the so that you not be confused. As long as, take note please, it is very, very important you watch what I say. Don't go and confuse or misunderstand what I'm saying. As long as the angle is to the horizontal, any component of a vector quantity in the horizontal direction is cos theta. I don't want to know as long. I emphasis on as long as the angle is to the horizontal, any component of a vector quantity in the horizontal that is cos, any component in the vertical direction is sine. But if I switch my angle to the vertical, it's inverse. It's not inverse. This is why in projectile, the time of flight, you notice time of flight is what? T sine theta. But if they give you the angle to the vertical, it will change to T cos theta. So when you see some textbooks solving time of flight and they use T cos, you're not like, no, this is, no, they are actually correct. The reason is because their angle is now to the vertical. I hope you are getting what I'm saying. The reason for that is because the angle is not to the vertical. So if you change their angle, because if the angle is to the vertical and you went ahead to use that vertical angle for this sign, you have gotten the wrong answer. Are you following now? So as long as the angle is to the horizontal, your horizontal component is cos, your vertical component is sine. But if the angle is to the vertical, your horizontal component becomes sine and your vertical becomes cos. So this is why, in order to avoid confusion, if you want to cram, okay, if you have crammed already, anything horizontal is cos, anything vertical is sine. If you want to cram like that, just make sure the angle is always to the horizontal. So if they give you 30 degrees to the vertical, change it to the horizontal. How? Subtract it from 90, because the total angle between vertical line and horizontal line is 90. Are you with me? So it will be 90 minus 30, so it will be 60. So instead of, when people are using 30, you'll be using 60 because you want to maintain this thing. I hope I'm clear. So I've been able to explain that to us now. Let's move on to what I'm saying. So knowing this thing now, knowing that our anything horizontal is cos, anything vertical, this is tension, is the force. I want to resolve it. So first thing, since I said, remember I said it once, a vector quantity is making an angle you have to resolve it to two directions. So I'll resolve this my tension to two directions. I'll resolve my tension to the vertical direction. I'll resolve it to the horizontal direction. So resolution of this my tension to the vertical direction, since the angle is to the horizontal, it will be T sine theta, right? Because it's to the horizontal. Then this one will be T cos theta. Is that not it? I just showed you resolution of forces. How do we get this thing? Let me show you now. This is how they got it. So this is a right angle triangle, right? Is that not it? This is the angle, this is theta. Right? So if this is my T, tension, this is my Ty. Ty means tension in the vertical direction. This is my Tx. Tx means tension in the horizontal direction. So using SOHCAHTOA, I want to get for Y first. Opposite over hypotenuse. That's sine, right? That'll be sine theta, right? is equal to opposite is ty over hypotenuse t. If I cross multiply, what would I have? Ty is equal to t sine theta. Why am I having t sine theta as ty? Because my angle is with the horizontal. So t sine theta. That's why I say vertical side, t sine theta. Now let me get for tx. This is the angle, this is adjacent. Adjacent over hypotenuse. That's what? Cos theta is equal to tx over t. That's adjacent over hypotenuse. Cross multiply. My tx will become t cos theta. This was why I stated that as long as your angle is to the horizontal, anything to the vertical direction is sine theta. Anything to the horizontal is cos theta. So if I resolve this my t, just as I have done, if I resolve it to the vertical and to the horizontal, I will have t sine theta here, t cos theta here, which I have just shown us here. Do you get now? Good. So let's move on. I hope we are learning. So let's move on now. So after resolving it, the same, it's 2t we have. I've done for one. I have to do for this one too. It's equal. This one is t sine theta. This one is t cos theta. Good. And this is our w. So remember now, we say equilibrium. We are dealing with equilibrium. So the question tells us that this particular nail, when you nail a picture frame to the wall, is it not balanced? If it's not balanced, it will fall. So your picture frame that is on the wall is balanced. So this is the picture frame. So we say the picture frame is in equilibrium. Now the only way you can assume, another way you can assume that something is in equilibrium without the question telling you is, imagine a question telling you that a frame was nailed to the wall, and this is the diagram. Find this. By that, even without the question telling us that the thing is in equilibrium, we know that it is in equilibrium. How do we know? Because when I nail a picture, imagine nailing this board to the wall. I've nailed one nail here, just two nails. I just put two nails here on the board. But look at the board is not falling down. Why? Because the nail held it. So like this, the board is in equilibrium. So if I want to solve any question related to this board, I already know, even without the questioner telling me that this thing is, I already know from the board is not moving, and so it's in equilibrium. Similarly, even if the question does not tell me that this thing is in equilibrium, by telling that you nail it to the wall, you nail it, it will stay. Are you with me? So this is in equilibrium already because we have already nailed it to the wall. Are you following? So by that principle, knowing that it is in equilibrium, and from the principle of equilibrium, when a body is in equilibrium, means the forces in all directions are equal or they counterbalance each other. So there are two directions we want to look at. We have upward direction, downward direction, right direction, left direction. If this body must be in equilibrium, it means the forces acting at the right direction must be equal to the forces at the left direction. What is the force at the right direction? T cos theta. What is the force at the left direction? T cos theta. So we have T cos theta here, we have T cos theta here. It will cancel out. Now let's go to the second one. Upward forces. What are the forces acting upward? T sine theta and T sine theta. So we have upward forces T sine theta plus T sine theta is equal to, what is the downward force? The weight W. Are you following me? So T sine theta plus T sine theta will give us 2T sine theta. How? 1 biscuit plus 1 biscuit, 2 biscuits. As easy as that is equal to W. So divide. I want to make T stand alone, so I divide both sides by 2 sine theta. Remember in mathematics tells us that whatever you do to the left hand side, you must do to the right hand side. So sine theta will cancel sine theta, 2 will cancel 2. Then we'll have T is equal to W over 2 sine theta. Are you there with me now? So by so doing, this particular formula here is a formula you can use to solve anything that once you see the diagram and it looks like this, you don't need to do all this nonsense I have done. Just remember this formula: T equals W over 2 sine theta. So if the question says I should find T, all I have to do is impute my value for W that the question gave me, put my theta here, and do my mathematics. I'm done. If the question says I should find W, all I have to do is say W equals 2 sine theta, 2T sine theta. Just look for any of them, whatever they say you should find from this formula. Are you with me? Now, what actually drove me here, or what actually brought me to this point in helping you explain, is that I remember a question like when I was doing my post-semi. I think a question like that is in the physics, new school physics. You can check it out after this video. But look at one question I saw here. Although it's not calculation, but it's theoretical. Imagine finding this question in your exam. How would you have solved this? So let's see. They drew this diagram from the question. They drew this diagram, and they said the diagram shows a uniform plank. In this case, now they call this one a plank, not a picture, not a bucket. A uniform plank of weight W, this is the weight with W, supported by 2 strings, which we have seen, inclined at an angle of theta to the horizontal. They made mention of it. They are even wise. That's why they put it to the horizontal. If you want to confuse, they put it to the vertical. Then you'll be confused. What did I tell you? If like the angle was here, what do you have to do? 90 minus theta. You get your angle inside. As simple as that. They now ask us that which of the following statements are correct? I. T increases as theta increases. I. T decreases as theta increases. I. T is maximum when theta is 90 degree. IV. T is minimum when theta is 90 degree. Now let's see if this is true. Now imagine you meet this kind of question. Many of us will not start solving. We not start solving. Even the solving we are solving one. Now imagine solving without value, without number, without value. You'll be so confused. So that's the theoretical question. Now let me show you how to get that. This is why I said once you can learn this one stone can kill so many birds for you. Once you just say anything like that, I've solved so many physics questions. So I know all these tactical questions. There's one test called College of Physics. This kind of questions are many there. I remember those days. I finished all the questions there. Let's see how we can answer that question. This is the formula, right? T equals W over 2 sine theta. This is the formula we want to use to answer that question. The first thing the question said, he said, if theta increases, I want to rub off this place. I believe you have copied it already. If you have not, you can take the video back later to what. If the first option says if theta increases, it means T will increase too. Is it true? First thing we have to organize or know here is that T and theta, they are inversely proportional. You can see it now, inversely proportional, because if I put over 1 here, this and this, so they are inversely proportional. And in mathematics, when something is inversely proportional, as one is increasing, the other will decrease. Inverse proportional or inverse proportionality. Now I want you to know that if theta is increasing, sine theta will be increasing. For the sake of us who are not mathematics or who don't understand, will be confused. Let me prove that to you. If my theta is 30 degree, 60 degree, and 90 degree, then let my sine theta be what my sine theta. Sine 30 is what? 0.5. Sine 60 is what? 0.8660. Sine 90 is what? 1. Check it. As theta is increasing from 30, as it's increasing, is sine theta not also increasing? 0.5, 0.8. 0.8 is bigger than 0.5. 1 is bigger than 0.8. So you see that as theta is increasing, it means sine theta is also increasing. So we already established that from inverse proportionality, if one is increasing, the other must be decreasing. One says if theta increase, T will also increase. Is that true? No. So one is wrong. I is wrong. I said if theta is increasing, then T will decrease. Is that true? Yes, because I'm going to say the first one is no, then this one will be yes. So I is true. Then I said if T will be maximum when theta is 90 degree. So for me to solve this, I'll give value to W and theta. Let's see. Let our W be 5. I'm just assuming value so that we can get an answer for it. Let our W be equal to 5. So let's solve. From what the question said, if theta is 90, W will be maximum. Let's see how true is that. So if theta is 90, T will be equal to W is what? 5 over 2 times sine 90 is what? 90 is 1. 2 times 1 is what? 2. So that will be 5 over 2. That's 2.5. Now let's take the lowest angle, 30 degree. If theta is 30 degree, so we have T is equal to, impute it there, 5 over 2 times sine 30 is what? 0.5, right? 2 times 0.5 is what? 1. 5 divided by 1 will give us 5. Between 5 and 2.5, which one is maximum? 5, right? So you see that 3 is wrong. 3 says when theta is 90 degree, we have the maximum value of T. Maximum value of T means that we have the highest value of T, which was not true. Are you following now? But when theta was 30 degree, we had the highest value of T, which was 5. So when theta is 90 degree, we have the minimum value of T, not the maximum. So 3 is wrong and 4 is correct, because 4 say when theta is 90 degree, we have the minimum value of T. So in that way, the correct answer will be 2 and 4. And from that option is option D. You can see I've used one to kill so many birds. I hope you get what I'm saying. So that's that about that. Now let's move on. We'll be able to cover this triangle of forces. So we want to look at moment of a force now. Moment of a force. I'm able to understand the diagram and everything now. Okay. So we want to look at moment of a force. That's the next thing we want to talk about now. Moment of a force. Moment of a force. Moment of a force. So what is moment of a force? The moment of a force is the turning effect of a force about a point. This concept is actually a concept that many students used to have issue with. They have a lot of issue with it. But I'm going to be explaining this. I'm going to help you understand this in the video. It's not actually a difficult thing. So, moment of a force, what is it? The moment of a force is the turning effect of a force about a point. See, I used to say something. For you to understand any calculation in physics, the theory aspect, you have to have a good and bulk knowledge in it, because theory explains the practical. Are you with me? So I will give you a simple example for you to understand this. The door hinge. So the door hinge is a popular example that we used to use to explain moment of a force. So let's say this is the handle of the door, right? This is the hinge point, right? So when you want to open your door, where do you apply a force? Here. You bring it down. That's where you apply a force. Where will the force act? Here. I want to ask you a question. This is where the force will act. This is where you apply your force. Hope you see the difference now. Before this door can open, you have to hold the handle of the door, twist it, turning. The turning effect of a force about a point. See, you have to realize, please follow me. You have to realize that what matters is not just the force, it is where it is exerting the effect. The effect of the force is felt at this point. This is why you see, when we are talking about moment of force, we say the turning effect of it is about the point. Mathematically, when we are describing the moment of a force, we say it is the product of the force and the perpendicular distance. What is moment of a force? Product means times. Force times perpendicular distance. Are you following me? Force times perpendicular. Why do we use perpendicular distance? The reason we use perpendicular distance, this is the same. I am applying the force here. The effect of the force is felt here. There is a distance between the effect of the force and where the force is being applied. You can see the relationship between the distance and the force. Is that not perpendicular? Look at it. This is a perpendicular. Distance, force. This is why you see, when we are dealing with moment of a force, we do not make use of horizontal distance. Rather, we make use of the perpendicular distance. So many a time you will see some question, they will give you some diagram, and they'll say, what is the moment of the force? Lo and behold, they will give you the angle, they will give you the force, and they will give you the distance. Let's say they will give the force to be 2 meters and give the distance to be 2 meters. They say 2 times 2, 4. But the answer will be 0. Why is it 0? Let me give you an illustration. Imagine something like this. P, Q. And they put a force of 2 newtons here. And they put a distance of 1 meter. And they ask you, they say the force here is F. What is the moment of this force F about point Q? The answer will be 0. You'll be wondering, why is the answer 0? The answer is 0 because for movement to occur, remember I was saying movement of a force is the turning effect of the turning, T-U-O. This is the actual word, turning. Turning effect of a force about a point. If you get to your door handle and you place your hand on it like this, and you place your hand on it, will the door open for you? No. The effect will be produced, the result will be seen until a turning has been made. Until you turn, the door will not open. The turning effect of the force about a point. So here, for this force to have a movement on this point, the force has to be turned. And if the force is being turned, it is turned through a perpendicular distance, not a horizontal distance. So this distance cannot give you the force, cannot give you the turning we are looking for. So the distance that is turned by this force to produce an effect here was not given. The distance is taken as 0. So 0 times 2 is what? 0. This is why when you see a question like this, and they ask, you see a diagram like this, and they say, what is the moment? You will know that the answer is 0 because there was no distance to describe the turning effect of this force. The distance given is not the one that actually describes the turning effect of the force. I hope you are following me. So the moment of a force is actually the turning effect of the force about the point. And it is force times the perpendicular distance. Important emphasis on perpendicular distance. Now, having said that, there are some cases or scenarios where our distances are not completely perpendicular and are also not completely horizontal. In a case where I have something like this, if I have the point here, okay, and I have the application of the force here, and I have the distance here like this, then this is the horizontal. Then they tell me theta, they tell me A, and they tell me F, and they tell me that, and they asked me that, what is the moment of the force about this point Q? What will be my answer? Now this is it. A simple example I will use, a simple realistic example I will use is, let's say your door hinge got spoiled. Let's say your door hinge got spoiled, and because the door handle got spoiled, because it got spoiled, it is not staying fully horizontal. The door handle is staying something like this. It's not staying like this. It's staying like this. So when you want to apply a force, you hold it from here and twist it before you open. That's the case scenario here. So although it is not directly vertical, like to give us a perpendicular distance, what we do is that we resolve the distance. Into the perpendicular direction, because for a movement, we said before movement there must be turning effect, right? So remember, I will have to turn my door handle to this direction before the door will open. So my distance have to be in this direction. So I will have to resolve my distance or my displacement to the horizontal component. And I showed us that anything horizontal is what is cos. So I will resolve my A. My A will be A cos theta. The vertical side will be what? A sin theta. Am I making use of the sin theta? No. Why? My sin theta and F are in the same direction. My F have to be turned through 90 degree first. So my F will be turned through 90 degree to where this A is. So the distance I'm using, this cos theta, always have at the back of your mind that it is the perpendicular distance perpendicular to the force is what we are using. Perpendicular distance is a distance that make an angle of 90 degree with the force. So this is A cos theta I'm using. Another way you have to know, or another thing you have to know, is that if the distance and the force are going in the same direction, you are not using that distance. That's another thing. This is the distance, this is force. You can't use it. So we're using the perpendicular one. So in this case scenario, if you want to find the moment, the answer will be, since moment is force times perpendicular distance, and the perpendicular distance here is A cos theta, the answer will be F times A cos theta. That will be FA cos theta. Are you with me now? So the answer is FA cos theta. That's actually what moment of the force is. Let's take some examples and see how true what I'm saying. Some past question rather. So it's not that I'm not capping, or what I'm saying is not. Don't forget, it's the turning effect of a force about a point. So let's look at this example here. Some example here that we have. So look at this particular example. They said, so they drew a diagram, something like I've just touched now. They said force F, and they put a point here, distance A, they call it X, and they said this angle is theta. And the question was, so the question says I should find, question said, in the diagram shown, this diagram, the moment of the 5 Newton force above about point X is what? The moment of this 5 Newton force, this force F, about point X is what? So we already know. I just showed us that diagram. So we already know what the answer. We have to resolve the distance to result. So that the answer will be FA cos theta. Now what is the option? The option here they said A FA sin theta, B FA tan theta, C FA over cos theta, D FA cos theta. So the answer is D, FA cos theta. And that diagram they showed here, just like that one I just described, we call this one point R, point Q, and point P. 3 Newton and 3 meter. 3 Newton, 3 meter. The question was now like, if PQ is 2 meter, PQ is 2 meter. 2 meter. Find the moment of the force 3 Newton about the point P. Find the moment of force 3 Newton about point P. The options were A 6 Newton meter, B 5 Newton meter, C 1 Newton meter, and D 0. The answer is 0. We already know. So if you can put it 3 times to 6. Because say because you not because you believe that movement is always force times distance, force times that. Now you get it wrong. It's not just force times distance. So there's a brother to this movement that actually looks very the same with the same is work. Work is force times distance, because for work to be done, a force has to be applied and the object need to move in the direction of the force before we say work is done. So work is done when a force is applied and the object moves through the direction of the force. That is when work is said to be done. Are you with me? So although moment and force has the same Newton meter and both are dealing with force and distance, the difference is that force is always, the force and the distance must be in the same direction. Are you with me? When I explain concept of work, I'll show you other things you can see related to work. Therefore, movement, the thing must be perpendicular. It must be perpendicular. Now, having understand movement, I want to show to us what it means by clockwise and anti-clockwise, then talk about principle of movement, then solve some questions, some jam and post questions on that. So let's look at clockwise and anti-clockwise first. So since movement actually deals with turning, movement deals with turning. So movement is talking about turning. That's what movement is talking about. Okay. So in your wall clock, you have your wall clock now. You have 12, 3, 9, 6. Your clock turns through like this. This is what we call clockwise. When we say clockwise direction, we mean direction of clock. So when something is moving like this, it is clockwise direction. And anything moving opposite to something, most time we call it what anti or anti, anything you want to say. So when the direction is against the direction of clockwise, we call it anti-clockwise. So a movement, the movement of a force in the clockwise direction is called clockwise movement. The movement of a force in the anti-clockwise direction is called anti-clockwise movement. So the movement of a force in the clockwise direction is called the clockwise movement, and in the anti-clockwise direction is called the anti-clockwise movement. So let's look at other things. The principle of movement. Now I want to talk about the principle of movement now. What is the principle of movement? What does this principle state? The principle of movement is simply saying that when there are two principles, when a body is in equilibrium, okay, because when we say force now, force now, the force under movement now is talking about force of turning, force that bring about turning. Sometimes that kind of force is called torque, though. So that force that brings about turning. So since we are dealing about turning here now, there's a principle that actually show to us the turning effect of a force. So when a force is beginning to bring about turning, because that's turning effect of a force now, that's the movement, is that not it? So when a body is in equilibrium under action of forces that can bring it into turning, the principle of movement is saying that one, the force that is acting on that body, when a body is in equilibrium, there are two forces that can act on it. Remember earlier part of this I said when a body is in equilibrium, it does not mean that it is just moving in a straight line. When the body is also not rotating, because rotation has to be considered. Don't just consider linear motion, consider rotational motion too. The body, before you say the body is truly in equilibrium, in rotational motion is balanced. In direct motion or linear motion is also balanced. So there's a rotational motion, that's torque. Okay, there's a rotational motion actually. So when a body is in equilibrium, two things we have to consider. We have to consider the movement of the forces on the body, and we have to consider the forces acting in all directions, which we have seen before. Left side must be equal to right side. So the principle of movement is checked in two directions. One, in the direction of force, when all forces acting on the body is balanced. That is, when upward forces equals downward forces, when the forces at the right equal the forces at the left. Two, in the action of movement, that is, when the clockwise movement is equal to the anti-clockwise movement. Now let me show you what I'm saying. So if I say a body is in equilibrium, two things that must be considered. The forces acting on this body must be equal, must be balanced, must counterbalance each other. That's the first principle of movement. They must counterbalance each other. That is, upward forces. If I have a force here, and a force here, and a force here like this, for this body to be in equilibrium, these three forces must counterbalance. If this one is 3 Newton, and this one is 5 Newton, this one must be 8 Newton for this body to be balanced. That's the first thing in terms of force. Then the other one in terms of movement, that is, the movement of the force in this anti-clockwise direction must be equal to the movement of the force in this clockwise direction. When this case scenario is met, then we say this body is in equilibrium. That's what the principle of movement actually states. Now let's quickly look at parallel and coplanar forces. Many times students don't understand this. What are parallel and coplanar forces? So parallel and coplanar forces is simply okay, I'm going to talk about something under these conditions for parallel and coplanar forces. This thing I just explained now is actually the conditions for parallel and coplanar forces. The principle of movement is actually stating that movement, when a body is in equilibrium, clockwise movement is equal to anti-clockwise. That's just the principle. The principle of movement states that when a body is in equilibrium, clockwise movement is equal to anti-clockwise movement. So this stuff I just explained is actually a condition for parallel and coplanar forces, which I'm going to throw more light when I reach there. But let's first understand what are parallel and coplanar forces. A parallel in mathematics, when we say something is parallel actually means that the thing is their line of action do not meet. Is that not it? When two lines move in such a way that their line of action never meet, that's this thing is parallel. Do you understand? It is parallel. Please. Are you with me now? It's said to be parallel. So when the lines of action of when two lines, their line of action do not meet, then the thing is said to be parallel. Let me show you an example. Let's say I have a line like this, and I have a line like this. These two lines, no matter how I draw them, no matter what I do, their line of action can never meet. If I keep drawing, they can. That's what we mean by parallel. So when we say parallel forces, we mean forces that their line of action do not meet. No matter what, they never meet. That's what we call parallel forces. So if I have something like this, if I have a body like this, and a force is acting on it here, a force is acting on it. These two forces are parallel. These two forces are parallel. This is a parallel force. Are you with me? So coplanar forces mean coplanar. The word co means the same. Planar come from the word plane. So coplanar forces mean two or more forces that are acting on the same plane. So this force and this force, they are acting on the same plane. This is the plane. So it means that these forces are coplanar. If I have a separate plane like this, and this is a third force acting here, these three forces are not coplanar because these two are coplanar acting on the same plane. This third one is acting on a different plane, so they are not coplanar. So when I say parallel and coplanar, we mean that these forces that are parallel and at the same time acting on the same plane. That's what we mean by parallel and coplanar force. So a parallel force, so when the equation tells that these forces are parallel and they are coplanar, this is what I'm talking about. It's looking like this. And there are many questions that used to come from this aspect. So let me give us a popular example before we start solving questions. So look at this now. Now let's talk about the conditions for parallel and coplanar. Now I've understood parallel and coplanar forces. What are the conditions for parallel and coplanar? The conditions are just two: force and moment. The first condition states that if two forces are parallel and coplanar, for that forces to be in equilibrium, one, the forces must balance each other. Upward forces must be equal to downward forces, and clockwise movement must be equal to anti-clockwise movement. So let's say we have something like this. This is the balance point. We have a force F1, we have a force F2. Are you with me? And we have a force F3. Are you with me? This is the balance point, okay? That's where the force actually balance. So for this, and you know that these three forces are parallel, their line of action cannot meet, and they are also coplanar. So for this thing to be in equilibrium, the first thing we have to know is in terms of force. In terms of force, the total forces must be equal. So the only forces acting on this body are three, and they are acting upward and downward. So in terms of force, the condition in terms of force state that F1 plus F2 must be equal to F3. This is the first condition. Upward forces must be equal to downward forces. The second condition is in terms of movement. In terms of movement, say that clockwise movement must be equal to anti-clockwise movement. Are you with me? So clockwise movement means in the direction of clock. So now anytime you want to get your clockwise and anti-clockwise movement, you always measure in. So remember I said when I was talking about movement of a force, I said it is the turning effect of the force, right, about a point. That is, when the force is applied, there is a point where the force exerts its effect. This force here, F1 here, the effect of this force is exerted at this. This is the point where all these forces are exerting their effect. Remember your door hinge. Your door hinge, when you place your hand on the handle, the place where the effect is seen is at the point. At the point, that's where it is seen. That's where you find the turning effect of the force about a point. So the point where the effect of the force is felt is where you measure the distance. Because remember the door hinge. This is my door hinge, and this is my force. So the distance of the point where the force is exerting its effect to where the force actually is applying, that's the distance. So if this is where the balance point of this is where the thing become balanced, this is where the effect of the force are felt. So if I want to get the distance of this my F1, I will measure where it is applied to the point where it's exerting its effect. If I want to do for F2, I'll measure where the force is applied to the point where it's exerting its effect. If I want to get for my F3, I'll measure where the force is applied to where it's exerting its effect. These are the distances of the force. So now I want to get my movement. If I want to get my movements now, therefore, since clockwise movement must be equal to anti-clockwise movement. So clockwise movement, this is clockwise movement. Anti-clockwise, okay, let me just say anti-clockwise movement is equal to clockwise. It does not matter which one you put first, though. It does not matter. So this is the one that is anti-clockwise. No, it's not even anti-clockwise. Look at it. Sorry. It's not anti-clockwise. Because if you look at it, how do we get this? This is the balance point, right? This is where we're measuring their distances from. So if I want to measure the distance of F1, this is the direction I will go. If I want to measure the direction of F2, this is the direction I will go. If I want to measure the direction of F3, this is the direction I will go. Are you seeing it now? I will not measure F3 like this. This is how I will go. So F3 is clockwise, F1 is clockwise, F2 is anti-clockwise. So clockwise movement must be equal to anti-clockwise movement. This is the second condition. The first condition is in terms of force. The second condition is in terms of what? Movement. So what is clockwise movement? So let me call the distance of F1 to be x1, distance of F2 to be x2, distance of F3 to be x3. S3 and S1 are not the same. I hope you know, see the diagram. So let's go. So clockwise movement, this is first one. F1 times x1 plus another clockwise movement, F3 times S3 is equal to anti-clockwise movement, F2 times X2. This is how the conditions are. So with this now, we can use to solve. So if the question says I should find X2, I'll put in my value and make S2 subject to the formula. So in this way, this is how they solve question on movement on a plane surface. So when they give you question answer, it's not difficult. This is how they solve it. So let's take some examples and we'll be able to. Now, before I also proceed, let me quickly explain something on center of gravity. Before I solve question, let me just finish this thing and explain some things. So have this at the back of your mind, though. Now let's move to conditions of equilibrium of non-parallel coplanar. Non-parallel coplanar. I didn't write that. Sorry. Non-parallel coplanar. So we already understood what parallel and coplanar means. But if I say non-parallel and coplanar, we already know what coplanar is. Let me just explain non-parallel. Non-parallel means their line of action meet. They are not a parallel line. So if I have a line like this and I have another one like this, are they parallel lines? No. Because if I draw this one continuously, at a point it will meet with this line. So they are non-parallel. So how do we have non-parallel coplanar this thing surface? This is how it is. Very, very easy. So this is how you draw it. If you have something like this, you have a force like this, F1, and you have another one like this, F2, theta. And this is the balance point. So if I draw this one like this continuously, and at the point they meet, so this is a non-parallel force. Although they are non-parallel, but both of them are acting on the same plane. So they are non-parallel and they are coplanar. That's what we mean by non-parallel coplanar force. So when you see a diagram like this, you don't know, oh, this is a non-parallel coplanar surf. But when you see a diagram like the other one I just finished explaining, you say this is a parallel and coplanar. So when you see parallel and coplanar, what do you do to solve? There are two conditions. Condition in terms of force, condition in terms of movement, which I've explained. So when you see in terms of non-parallel coplanar, it also has two conditions. Condition in terms of force, condition in terms of movement. And the sweet thing about this is that both conditions are the same. The only difference is that in this one, what you do, first of all, convert the non-parallel force, convert it to have a parallel force. How do you do that? You resolve it. After to resolution, you resolve into two directions. So I'll resolve here, I'll resolve here. So my F2 in the vertical direction was F2 sine theta. Why did I use sine theta? Because the angle is to the horizontal, which I've explained before. My F2 in the horizontal was F2 cos theta. Now the question is, out of these two forces, which of them, notice the balance point, oh, out of these two forces, which of them would I use to get movement? Is it F2 cos theta or F2 sine theta? F2 sine theta. I can't use F2 cos theta. Why? F2 cos theta, if I have to trace the distance, it is going in the same direction as the balance point. You can see it's the same. It's not perpendicular. And what does moment say? It is what? The perpendicular distance. This one does not have any perpendicular distance. So the moment of F2 cos theta about this point is zero. So we are crashing this one out. What we are using is F2 sine theta. So after changing our F2 to a vertical side, now we can now use the same direction, the same method we used for the previous one. So if I'm to find the moment of this one now, if this is x1 and this is x2, right? Then I will say moment, clockwise moment is equal to anti-clockwise moment. That will be F1 times, let me clean this. That will be F1 times x1, that's clockwise moment, is equal to anti-clockwise moment, is equal to F2 sine theta times x2. This is how you now solve it. You're not using F2 now because F2 is just slanting. I hope you got what I'm saying. So I'll say F2 sine theta times x2. So here now, if they want me to find F2, I'll make F2 subject to the formula. If they want me to find sine theta, I'll make sine theta. So anything they want me to find for me, I'll be able to get it. So this is how you solve for non-parallel coplanar forces. Now, next, I've explained this now. Let's now talk about the last one, moment of a couple. What is the moment of a couple? Moment of a couple is actually, what is a couple first? A couple is actually a system that is a system of arrangement where two forces act opposite, two parallel forces that are opposite in direction. You can see this in your tap. So your tap is made such a way that if you want to twist it, So you see that in tap, in bicycle, your bicycle, exactly. So two forces, F1, F2, equal forces, so with a distance between them. This is what a couple is. This is what we call a couple. So when two forces are acting, two equal forces are acting in opposite direction with a distance between them, that's a couple. So how do we get the couple? The answer is very, very simple. Simply, that's where the torque came from. TORQE, torque, actually, because it is a force that brings about rotation. So it's actually simply just pick one of the force and multiply the distance between them. So if the distance between them is 3 meters, and each force is 2 meters, 2 meters, that way 2 times 3, 6. So it's not difficult. So a couple is just this is a system of a couple. So just pick one first and multiply it. Good. So that's just it. Now, before I start solving questions, I want to quickly explain something on the center of gravity. I want to quickly say something. I'm not going to be writing more because that's just theoretical. I'm just going to explain center of gravity. What is the center of gravity? Is actually a center, a point where the line of action of a person passes through, or the point where the weight of a body acts. For anything, for your meter rule, the center of gravity is always at the middle. So the meter rule is that thing that is used in the physics laboratory, that yellow one. The total length of the meter rule is 100 centimeter or 1 meter. Take note. So the center of gravity will always be at the 50 centimeter at the middle. That's where the center of gravity always is. Are you following me now? So the center of gravity of a meter rule is always at the middle, which is 50 centimeter or 0.5 meter. Now, sometimes that question they will ask you using the meter rule, they tell you, once a question tells you a uniform meter rule, just know that it's the complete one, 100 centimeter. If they tell you a half meter rule, just know that it is the incomplete one, 50 centimeter. So you know how you can position yourself. Please take note. And another thing I want to tell us again is that understanding center of gravity will help us better, or will help us to solve question better on this movement of a force. There are a lot of so much things that we can say, but then just to make the video not to be too long, I've just given you the whole foundation. If you still need extra classes on those, you have to register in our paid classes. Yes, we have paid classes that we have one-on-one classes with students and the rest of them. But let's just continue. This is just a video to just help you understand, give you a background knowledge on what we're trying to talk about. But what I'm trying to say so far is that once you get a good knowledge on center of gravity, you are good to go. There's also what they call stability. It's also under equilibrium. So stability is when the body is stable. We have stable equilibrium, unstable equilibrium, and we have neutral equilibrium. Those things we used to explain in our paid class. So when you register, you get that. Let me just deal with the example so that we can wrap up this video. So let's see some examples, some question. Look at this particular question now. I will read it out so that we will not solve it. I'm not going to write the question. I'll just read it out so that we'll be able to solve it. So it says that a meter rule is pivoted at its center, has masses M1 and M2 placed at the 20 centimeter and 65 centimeter mark, respectively. If the meter rule balances horizontally, the ratio of M1 over M2, M2 over M1 is what? Now, this is what the question is actually asking us. Very, very easy question. It says a meter rule balances horizontal, and I just said that what is the total length of a meter rule? Is 100 centimeter in centimeter or 1 meter. So this is our meter rule here. They said the meter rule balances at the center. So between, let me call the meter rule A, B, meter rule A, B. So between point A to B, the total length of the meter rule is 100 centimeter. If it is balancing at the center, that'll be what? That'll be the 50 centimeter mark. So here is 50 centimeter, right? The question now went ahead and said two masses M1 and M2 are placed at point 20 centimeter and 65 centimeter respectively. So this is 0 centimeter mark. This is 100 centimeter mark. You can see how to describe and understand question. This is 0 centimeter mark. This is 100 centimeter mark. Okay. Now, then I said the first mass is balanced at the 20 centimeter mark. So this is 20 centimeter mark. Sorry, first mass M1, 20 centimeter, mass M2, 65 centimeter. Are you seeing it now? They now ask us now. The question is now asked, what is the ratio of M2 over M1? What is M2 over? This is the question. Now imagine seeing this question in your exam. This is a past question. What will you do? Now, always know M1 and M2 in this case, they are serving as our force, because if you find our weight, you get a force. They're serving as our force. So, what kind of this is this? Is this parallel and coplanar or non-parallel and coplanar? Good, parallel and coplanar. What are the conditions for parallel and coplanar? There are two: forces and movement. But in this case now, what we are looking for is the movement. We are dealing with movement. So the condition we are going to use is the movement condition, right? And what is the movement condition? Clockwise movement must be equal to anti-clockwise movement. Good. I love the way you are following. Now the next question is, when we are dealing with movement, what point do we take as our balance point? Very good. The point where the meter will balance. So these are our balance point. Good. Now the next question is, when we are measuring our force, are we measuring to this side, or we are measuring to the balance point? We are measuring to the balance point. Very good. So my M1, the distance of my M1 will be between here and here. Let me call it X1. But the distance of my M2 will be between here and here. Good. Let me call that X2. Are you following me now? Good. So by principle of movement, anti-clockwise equals clockwise. So this is anti-clockwise, this is clockwise. So my anti-clockwise movement is equal to my clockwise movement. So my anti-clockwise is M1 times X1, right? M1 times X1, M2 times X2. Is that not it? Now, what is my X1? What is my X2? From here to here is 20. From here to here is what? Good. 30. Because if here to here is 50, 50 minus 20 will give me 30. Exactly. From here to here is 50. From here to here is 65. What is here to here? Good. 65 minus 50 will give me 15. Are you following me? That's 15. So my X1 is 30. That will be M1 times 30 is equal to M2 times 15. I'm looking for M2 over M1, right? So divide both sides by M1. This will cancel this. So we have M2 over M1. Then we'll divide both sides by 15. So we have M2 over M1 is equal to 30 over 15. That's 2 over 1. The ratio is 2:1. As easy as that. Is this thing even difficult? No. Let's solve some other questions before we call it a wrap. Now, there's actually a point where I'm not going to solve questions on that, because that particular one is actually made for students who register for our private classes. Yes, that's a very difficult. A point where many of you, those of you that are soft, you might have seen something like this, right? And they'll put some forces and in movement of a couple. Yes, it's actually very easy, but I'm making a video especially for this kind of questions, a special video for my students who register for our class. And meanwhile, if you're a JAM student, a post-UM student, or any student, a student who are writing the exam, you can send a message to the number you see on the screen, or this number I'll put on the board now: 070 36 59 30 57. 070 36 59 30 57. So you can message us to join our classes. We hold classes on Telegram, WhatsApp, and we also do video classes like this just to help our students learn. So let's continue now. Now let's solve one more question. Now look at this particular question. They said, okay, let me draw the diagram. These are they put it, and they put this stuff here, and they call this R. And they said this side is point P, and this is point Q. So between point P and point Q is 15 centimeter. And between point Q and point R is 30 centimeter. And let's see the question. Then this Q is 9 Newton. Let's do the question. The question says, a rod PR is balanced on a pivot. It's balanced on a pivot, okay? At the end R, while a string is used to support the rod at point P. A string is used to support the rod at point P. See the diagram. The weight of the rod is 9 Newton. And it's acts at a point Q, where QR is 30 centimeter and PQ is 50 centimeter. The tension in the string is what? But to find the tension, this P, this T here, that's what we're looking for. Very, very. So these are our balance points. Is that not it? So movement, just principle of movement. Anti-clockwise movement equals clockwise movement. So let's go. This is anti-clockwise. This is clockwise. So the distance between, now this is where the force is exerted. T, right? Where is the point? Where is this effect produced? The effect is produced here. So the distance will be from here. See, this is how you get your many. The point where students find issue in this thing is not even is how to know their distance and how to get their respective subtraction on this. It's very easy. The point where the force is exerted, measure the distance from there to the balance point. That's how you get your distance. Many students here, when they want to do, they will use this. They will say they will use 15 centimeter. Or some will even use 30 centimeters, but that's wrong, because our T is exerted here, and the distance of our T to the balance point is from here down to this place here. That's 15 plus 30, 45, not 30, not 15. So clockwise movement equals anti-clockwise movement. By solving, so I will say 15, sorry, T times 45 is equal to 9. So the distance between Q and R here is 30. 9 times 30. Divide both sides by 45. T is equal to 15 in 45. 3. 15 in 32. 3 here 1. 3 9. 3. 3 times 2. That's 6. T is 6 Newton. As simple as that. There are also many questions we have here. Okay, let me see if I can see one question on non-parallel. Okay, I think I have one. That's the last question I'll be solving. If you want more questions or you need more explanation, or you can drop your question on the comment section. Don't forget to follow us. I'll solve one more question. Let's go. One more question. Now, this is how they drew the question here. They put it this way, and they brought it like this. They call this one arrow. This side was this point arrow. This 30-degree, and this is the balance point Q. Put a mass here, and they put 2 meters. And this is point P. This is 50 kilogram. The mass is 50 kilogram. And between Q and R, they put 10 meters. Now let's read the question. A load of mass 50 kilogram is placed at the end P of a light beam. PQR. This is a light PQR. Okay? And they said it should be lifted by applying a force F at the end R. So they apply a force F here at the end R. If the beam is pivoted at Q, and F is inclined at 30 degrees to the beam, the minimum value of F needed to lift the beam is what? So this is what we call non-parallel coupling, because the weight of this thing will act here. Is that not it? Here the weight will act. If you draw it down, they will meet at a point. This is non-parallel coupling. Okay, so we'll resolve. I've shown you. So this will be F sine theta. This will be what? F sine theta. Is that not it? So they want us to find the minimum value of F. So this is F sine theta. If I resolve it, is that not it? I've shown you before now. So this should be F sine theta under resolution. So I'll find the weight of my load as 50 times 10. That's 500 Newton. This is the balance point. So by principle of movement, clockwise movement is equal to anti-clockwise. That will be 500 times 2 is equal to F sine theta times 10. You can say I'm using 10, not 12. Just know the balance point. It's the balance point at the center. I did not say F times 10. I said F sine theta times 10. You know the reason why I said so now. So this will be F sine theta times 10. I'm using F sine theta because we need to resolve it. So divide both sides by 10 because I'm looking for F. 10 will cancel 10. So we have 50 times 2. You cannot press your calculator straight though. So we have 100 is equal to F sine theta. They gave us sine theta to be 30. So sine 30 is what? Sine 30 is 0.5. So we have 0.5 times F is equal to 100. Divide both sides by 0.5. 0.5 cancels 0.5. You have F equals 0.5 times 100 divided by 0. That's 200. So the answer is 200 meters. It do not even take me 5 seconds to solve these things if I was the only one. So the stuff is not difficult. Where the issue actually lies, your ability to interpret the question to this point and your ability to follow the conditions. There are conditions for each of all of these things. So guys, we have come to the end of this, and I believe you actually learned something. We have been able to talk about, understand the concept of equilibrium, resolve, resultant, and equilibrium of three forces, moment of a force, principle of moment, parallel coupling, and so many other things. And I also want to tell you that if you are watching this video for the first time, you watch to this point, thank you for watching. Make sure you subscribe to our YouTube channel, follow us on TikTok and on Instagram, even on Facebook. Just search for Tutor Glycol. You will get that. The name of our tutorial is actually Prominent Online Academy. So we take JAM classes, wire classes, post-training classes. So if you are in any of this category, or you are that student who is still in secondary school, you want to learn chemistry, physics in another dimension, another place, you can send us again, because we have various programs that help. We have a program called Chemistry Made Easy. We have a program called Physics Series. All of this program is just to help students understand concept. Okay, so make sure you follow us in all of these things. You can send me a message on WhatsApp using this number 0703659 3057. See you all. I remain your humble ethylene glycol. Thank you so much for watching the video to this point. God bless.